Okay, in this next video we want to talk about some of the basic math skills that we will use in this course. And one of the biggest area where I want to make sure that we have refreshed our memory and practiced a little bit before we move on into the first chapter of material is right triangles. Basic right triangle math is something you had in geometry and is something that I think most of you are familiar with. Start with the Pythagorean theorem, which is the easiest part of it all. If you remember correctly, the Pythagorean theorem, a squared plus b squared equals c squared. So for any right triangle, the length of the two shorter sides will squared added together will equal to the longer the hypotenuse side squared. So we can use this. We know two of the sides of a right triangle. We can use the Pythagorean theorem to find the length of the third side. The part that I think we struggle a little bit more with is being able to, when we know angles inside, start to use a triangle. So let's refresh our memory a little bit on the basic sides of a right triangle, and then we'll get into the basic formulas. If we have a right triangle, so we have a right angle here. We have our original starting angle. We'll use the Greek symbol theta to stand for angle. We have three sides to any right triangle. The hypotenuse is always the longest side. So this side up here will always be referred to as the hypotenuse. Based on where the angle is located, if it's here or if it's up here, but starting, we're going to use this angle right here. The adjacent side is the side next to the angle. The opposite side is the side opposite the angle. So hypotenuse, the long side. Opposite is opposite from the angle. Adjacent is next to the angle. There are three functions that we can use based on this. The first one is the sine function. Sine of an angle is equal to the opposite side divided by the length of the hypotenuse. So the sine of an angle is the opposite side divided by the length of the hypotenuse. The cosine of an angle, abbreviated COS, the cosine of an angle is the adjacent side divided by the hypotenuse. And the third formula is the formula for tangent. The tangent of any angle, abbreviated tan, is equal to the opposite side divided by the adjacent side. The easy way to remember this is a little mnemonic device that you probably have all used before. So, ka, toa. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. So SOHCAHTOA to remember those three formulas. Let's look at some example problems. This first one, we have a triangle with a hypotenuse of 45 meters and an angle of 35 degrees. We'll do a little drawing over here to give us an idea of what we're looking at. So this is 45 long, and the angle in here is 35 degrees. We want to figure out the length of the adjacent side and the opposite side. So in this case, let's start with the opposite side. We're looking for the opposite side. We know the hypotenuse and the angle, so we want to use the sine formula. Sine of an angle equals the opposite over the hypotenuse. So in this case, the sine, the angle in this case is 35 degrees, equals the opposite over 45. We cross multiply. 45 times the sine of 35 will give us the opposite side. Now in our calculators, a couple of things to be very careful of. One, you must make sure that the mode of your calculator is in degrees, not radians. The old TI-80 calculators default to radians. but you want to make sure you're in the unit of degrees. Press the mode button and make sure degrees is highlighted. So I'll type in 45 times sine 35. Hit enter, and I get my angle, my length of my opposite side, which in this case should be shorter than my hypotenuse if I've done it correctly, 25.8 meters. Second problem, find the adjacent side. This time we're going to use cosine of an angle equals the adjacent over the hypotenuse. So the cosine of 35 equals the adjacent over 45. So 45 times the cosine of 35 equals the adjacent. Plug that into our calculator. 45 times cosine 35. We get 36.9. So the adjacent side, 36.9 meters. Now, a couple of things to pay attention to. This angle is less than 45 degrees, so the adjacent side should be longer than the opposite. At 45 degrees, they will be equal, and greater than 45 degrees, the opposite should be longer than the adjacent. A couple of key things you can sort of look at to make sure you're doing it correctly. Second example problem. This triangle has an adjacent side of 20 and an opposite side of 15. So this is 20, this is 15. We want to figure out how long is the hypotenuse and what is this angle. For the hypotenuse, that's pretty straightforward. We can use the Pythagorean theorem. A squared plus b squared equals c squared. So it doesn't matter which side we make a and b. 20 squared plus 15 squared equals c squared. We do that, we get 625 equals c squared. Now we need to take the square root of 625. And we get 25 as our third side. So this hypotenuse is 25 meters long. The angle is a little bit more complicated. We're trying to find the angle and we know the opposite and adjacent side. This is where tangent would be most useful. You could actually use any of the three sides because we've solved for the length of the hypotenuse. I just think using tangent's the easiest because if you made a mistake in doing the hypotenuse, you don't carry that mistake into this next problem. So the tangent of our angle is the opposite side, 15, divided by the adjacent side, 20. Now this is where I commonly see mistakes. People take 15 divided by 20 and don't really know what to do to get the angle. Tangent is a mathematical function just like sine and cosine. To get rid of a mathematical function, we have to do the opposite of the function. So we need to take the inverse tangent of 15 over 20. Inverse tangent on your calculators is second tangent. 15 divided by 20, and we get 36.9 degrees. This makes sense just like the last problem. We said if it's less than a 45 degree angle, the adjacent will be longer than the opposite. In this case, 20 is larger than 15, so it should have been less than a 45 degree angle. So we do inverse tangent to solve for that angle out of the tangent formula. If you had the two sides in the cosine formula or the two sides in the sine formula, you would do inverse cosine or inverse sine to solve for the angle. Please bring any questions that you have on this with you to class.